Good morning, everybody. This is Dr. M. Nagapani Shastri, Associate Professor, G. Pullareddy Engineering College, Kurnool. Today, I am going to discuss about the basics of CAD, Computer Aided Design. How the design process will support the conventional design process, what are the elements of CAD, and the fundamentals of CAD, the basic design process, then the benefits of CAD, along with what is the configuration of the computer to use this computer in the design activity, the hardware as well as software components. Okay, so CAD, computer aided design, is the element, it is the definition that we can define as the use of a computer for the creation, evaluation, analysis of the design process, and identifying a good alternative design solution for the required one. So CAD/CAM means computer aided design and computer aided manufacturing. Aided design and aided manufacturing means the human being is making use of the computer system in the design activity as well as in the manufacturing activity. The technology, it is concerned with the use of digital computers to perform certain functions in design and manufacturing. What are these certain functions? So these are nothing but the use of computer systems to create an image, to modify. If you identify some corrections, you make modifications in that one. So when you are going for a design of a new process, you cannot limit yourself for simply one design. You may search design alternatives. Maybe some 3 or 4 design alternatives may comes in your mind, and accordingly you are creating. Then you are analyzing each of those designs, and you are evaluating their performance and picking out one particular one, optimizing that particular design, which will gives you more nearer results to you, to the satisfaction of you, and finalizing that design. So this is basically called CAD, computer aided design. So CAD can be defined as the use of computer systems for the creation, modification, analysis, and optimizing an engineering design. So the computer system which we are using for the design activity is obviously having 2 different configurations, the CAD hardware as well as CAD software. So what is this CAD hardware and CAD software? Before proceeding to that, we must discuss some more things about this CAD/CAM. So then what is CAM? CAM can be defined as the use of computer systems to plan, to manage, to control the operation of manufacturing plant through either direct or indirect compute interface with the plant's production resources. So earlier what we are doing in the conventionally, the human being, he himself on the white paper writing out all the procedure, the route sheet, and he is preparing the design schedule, the manufacturing schedule, and everything goes on his own. But we cannot confirm about whether it is optimized or sub-optimized. Whatever the idea that comes in his mind, we are going accordingly. But whereas in the computer-aided manufacturing process, computer will assist you to optimize the manufacturing activity also. So we discuss about CAM in the later sessions. Now let us proceed to the CAD process. So when you see the product life cycle and CAD/CAM, the various activities plus functions, that is completely product cycle. That is starting from the design of the component and manufacturing of the component, attracting the customer, putting it on the customer side, and sales to particular certain level. After you are giving good advertisement and all, it will reach its peak, and thereafter automatically it will decreases the product design. So this entire thing, that is the product concept which is comes in your mind, then goes to the design engineering, preparing the design and all, then drafting process. Then once that is drafting is over, it goes to the process planning activity, the root sheet and everything, order the new equipment and tooling if required for that particular process, then scheduling of the activity, then preparing the hard components, the components in your hand, that is the production. Then prepared components are undergo for quality checking, quality control. Then finally satisfied components will go to the market to reach the customers. This is entirely, we can call it as product life cycle. So in this product life cycle, in order to reach that one, the very basic thing is the CAD. So what is this CAD? What are the fundamentals of CAD? So computer aided design. Computer aided design. So the human being, the designer, is interacting with the computer through interactive computer graphics system, and he is preparing the designs. So modern CAD systems are based on the interactive computer graphics system. Interactive computer graphics system. So there is a communication between you and to the computer system. So whatever the inputs you are giving, computer is reacting accordingly and will give you a meaningful images on the screen. So ICs is a system in which computer is used to create the image on the screen, to transform it from one location to another location, or to increase or decrease the size, to understand it completely, and display the data in the form of pictures or symbols. So when you are going to create a rectangle, you select in any useful CAD package like SolidWorks or Creo or some other thing. When you click on the rectangle button, or when you are, it will ask you enter the lower left corner. Now you are giving the points. Then it will ask you the upper right corner. You are giving. So immediately it will display you the rectangle on the screen. In this way, the mathematical data given by you is displayed on the computer screen in the form of images. So this is in interactive computer graphics system. So the ICG system and the human designer are the major components of a CAD system. None of these alone cannot do any activity. Together they are doing, thereby it is called interactive computer graphics system. Interactive computer graphics is the tool used by the designer to solve a design problem. So in effect, the ICG system magnifies the powers of the designer. How? When you are doing it on the paper, whatever the idea comes in your mind, you are drawing it. When you are not satisfied, you erase it or you throw on that paper. So a lot of paperwork is waste there on the system. But when you do it on the computer system, simply you can erase and do so many alternatives for the ideas that you are getting. So this has been referred to as the synergetic effect. So increasing or magnifying the effect of the designer is called synergistic effect. The designer performs the portion of the design process. So computer on its own cannot creating the image. The designer is doing. That is most suitable to human intellectual skills. So what are the intellectual skills here? Conceptualization. When a new design, new order comes to you, first you come to an idea. So what are the components, subcomponents that are needed in order to create this particular component? So that is conceptualization. Then independent thinking. What are the various alternative solutions in order to create this image? Whereas the computer performs the task that is best suited to its capabilities. So what are the best suited capabilities of a computer? So speed of calculations. So we are far more less than the computer in the calculation part. And visual display, immediately it will create the image on the screen. When you are doing it on the black paper, white paper, so you are making use of scale, pencil, everything, and you are creating. That will take much of your time. But when you make use of the computer system, instantly it will give you images on the screen. That is the visual display. And whatever the information you have created, that will be saved and stored on a particular area. So as and when needed, you can retrieve that one. So these are the tasks that can be carried out by the computer system, and the resulting system exceeds the sum of its components. Finally, the completed component is displayed on the screen. So why we require the assistance of the computer in the design process. Fundamental reasons for implementing a CAD system means to increase the productivity of the designer. So when you give a computer and you have practiced in a particular software, I have given an example of like a screw jack or knuckle joint or some other thing. When two persons are sitting together, one is working on paper, one is working on the system. So automatically who is interacting with the computer creating will do it more speed and more effectively. Whereas in the paperwork, drawing sheet work, it will take much of time. So the time that you are taking for the creation of one image or one component on a paperwork, whereas in the computer system, if you do the same thing, you can produce more number of components for the same given time. So thereby the productivity of the designer is increasing with a more accurate and effective way. So to improve the quality of the design also. So to compare the quality of the CAD images compared to human worker, there is a lot much gap between. So the images that you have created, simultaneously you can visualize them in 2D, 3D views, all the 6 views, isometric views and orthographic views, everything you can see, the 2D as well as 3D. And you can add colors to the individual components also. But when you do it on the drawing sheet, all the views you must side view, top view, front view, everything you need to draw. But it is not required in the CAD system. If you create one image on the screen, automatically system will show you all the possible 6 views and with the different colors also. And to improve communication. So when you compare the prepared images on the paper and you are observing the same thing on the computer, the way of understanding is more easy in the CAD systems. So the communication, the way that you are communicating the information about the image and all is very good in case of CAD systems. And finally, our ultimate aim is to get the component on your hand, that is to prepare or to manufacturing the component. So to create a database for manufacturing, so all this created information is stored, so that will be given input to the manufacturing department in the later stages. So because of these reasons we are going for the CAD system. So before going to the elements of CAD system, let us discuss about what is the basic design process. The basic design process as supposed by Shigley is having 6 steps. Of course, it is an iterative procedure because if your new idea comes, you can erase the previous one and create. Continuously you are thinking, so many ideas are coming, so this may be good, no, this may not be good. Like that you can think and you can erase and you can do. So because it is thereby it is called iterative process. It consists of 6 identifiable phases. Number 1, recognition of need. So what is this recognition of need? When a new design requires, when the existing things are not giving comfort to you, you are not satisfied with the existing components, existing system. For example, if you take a two-wheeler or a refrigerator or some other thing. So a two-wheeler, what is the immediate requirement for us? Good mileage with low cost. So a new component comes to in the market. People will go and purchase that one. Then after using certain days, they will give you the feedback about that one. Mileage is not good, it is not giving this much comfort, back pain may be coming like that. So the designer will get all the feedback from you and consolidate all the feedbacks. What are the common things they will identify, and they will work on that particular area. How to improve the comfort on the seating, or how to improve the mileage of the component by reducing the weights and all, by implementing the composites on the various components like that. So recognition of need means when there is a need for a new system or some corrections are needed on the existing system. So that is called recognition of need. Once the need is identified, the next step is the definition of problem. So after consolidating all the ideas of the customers, after getting the feedbacks, the design engineer will define the problem. What is the problem area? How to satisfy the customer, how to give a good solution for their needs. So this definition of problem is having maybe some 3 or 4 different design alternatives. So because one may not exactly satisfy the needs of the customer, so he may define 3 or 4 design alternative solutions. Then we cannot produce all the 4 components or the 4 design alternatives with that specifications. So among these 4 or 5 alternative solutions, you must identify optimize one particular thing. So that is the next step called synthesis. He will work on that one, each and every design, and he will impose the boundary conditions and all, gives the inputs, create prototype models, and the experimental work he will carry out. So when he is doing in this activity procedure, among these 4, maybe 1 or 2 will give satisfied results. Then he will carry out analysis and optimization procedure. Still we require only one thing. So he will do all the analysis procedures on the components, the kinematic analysis, dynamic analysis on those design alternative solutions, and finally he will optimize one solution. So after identifying one particular thing, its performance is evaluated in the real world conditions. Once that is satisfied at the evaluation procedure, that will be given to the in a cleared way as a presentation to the manufacturing department. So in the presentation area, we have all the information about the design specifications, the lengths, everything, dimensional things and everything is given in the paper form. So this is called the basic design process. So here once again the points that we have discussed. Recognition of need. It involves the realization by someone that a problem exists for which some corrective action should be taken in the existing environment. This might be the identification of some defect in a current machine or completely perception of a new product. Any one of these things. Then definition of problem. It involves a thorough specification of the item to be designed. What are the requirements and everything. So this specification includes physical and functional characteristics, cost, quality and operating performance, everything. Then synthesis procedure. It involves the study of all the parameters individually for designing the products of its best. So because you are working on it, so our ultimate aim is, because in the competitive market, we require our design, our product should get more attraction from the customers, more orders. So we will work more on this one. All the parameters examined individually and are combined together so as to form a whole thing. Then analysis and optimization. Analysis is closely related to synthesis process. When you identify some error in the analysis, again it will refer back to synthesis. Thereby it is called a iterative procedure. Here the product is divided into its subsystems or subcomponents by the designer for their analysis. These subsystems gets improved through the analysis procedure and redesigned. Means again it is sent back to synthesis procedure. The process is repeated until the design has been optimized within the constraints imposed on the designer. So whether it is giving good mileage, increased mileage or not, the seating comfort is good or not, any other thing, aerodynamic effects are satisfied or not. Like that, depending on the component, the particular constraints are satisfied or not will be examined here, and it will be iterative procedure. Once you satisfied at this stage, optimized your design, then the next step is called evaluation. So the evaluation involves the measurement of design against the specifications established in the problem definition stage. At the beginning stage, at the definition of problem stage, you have defined whether your created model is satisfying that definition of problem stage or not. So that is evaluated here. This evaluation often requires the fabrication and testing of a prototype model. So at the laboratory level, you are preparing a prototype model and you are fabricating it and you are testing it against the given conditions by evaluating it operating performance, the quality, reliability and any other criteria that is associated with that particular problem. So once evaluation is over, what is next? You are satisfied with the new design. So then finally you are giving it for the manufacturing section. So that is called presentation. It is then the final phase in the design process. It includes documentation of the design by means of drawings, so that manufacturing engineer will easily understand what the component is, its specifications and everything, the material specifications, the assembly list. So all these things are very clearly mentioned at the presentation stage. So this presentation is the input for the next level, that is the manufacturing department. So this is all about the conventional SIGLE proposed design process. So when you identify the basic design process, there are certain areas where it is very difficult to the designer to carry out, because it is a laborious task at the synthesis level, at the analysis and optimization level, evaluation stage, even at the presentation also. So then the need of computer arises. So in this basic design process, where the computer will support you: recognition of need, definition of problem, synthesis, analysis and optimization, evaluation, presentation. Out of these, what are the areas at where the computer will assist you? Will the computer support you in the recognition of the need? No, exactly, because it is the need arise from the customers. So you collect the data. Then definition of problem, computer on its own will not define any problem. So the design engineer will define the problem based on the feedback that he is getting from the customers, from the recognition of need stage. Now the next step called synthesis. What is synthesis? You are creating desired alternative solutions. Yes, exactly. At this area, the computer will support you in the creation of the models. That is called geometric modeling in the CAD area. Then the analysis and optimization. Of course, you have beautiful analysis softwares nowadays. Engineering analysis will carry out. Then the evaluation, that is called design review and evaluation. Then finally presentation, you are preparing the hard copy of the things at the automated. So in the last 4 areas, that is at the synthesis, analysis and optimization, evaluation and presentation stage, we make use of the computer system, or the computer will assist you in these areas. So the corresponding terminology used for synthesis is geometric modeling. For analysis and optimization is engineering analysis. Evaluation is called design review and evaluation. Presentation is called automated drafting. So this is the basic thing of CAD process, computer applications to the design process. Let us see one by one very clearly. So now the geometric modeling. So it is the mathematical, computer compatible mathematical description of the object. A rectangle, if you say simply rectangle, computer will not create. So how you can create a rectangle? Mathematical description of the rectangle. What is it? Is maybe the 4 lines joined together perpendicular to each of them, or the lower left corner or upper right corner, in this way. A circle by means of its center and radius, like that. So that is called computer compatible mathematical description. When you click on the icons on the computer system, for example a circle, it will ask you enter the center. You will type the points, then it will ask you the radius. Once you have typed the radius, immediately circle will display on the screen. This is called mathematical computer compatible mathematical description. So geometric modeling is it corresponding to the synthesis phase in which the physical design project takes form of the ICG system. So the conceptual stage in your mind is taking physical shape on the computer system at the geometrical modeling stage. So in the CAD environment, geometric modeling is concerned with the computer compatible mathematical description. Computer compatible. It should not be not mathematically defined form. Should have mathematical description for the object that you are going to create, of the geometry of an object. The mathematical description. So what is this description? It allows the image of the object to be displayed and manipulated on a graphic terminal on the screen through signals from the CPU of the CAD system. So whatever you are giving from the keyboard and CPU, so it will create and give you the image on the screen. So to use geometric modeling, the designer construct the graphical image of the object on the CRT screen. So simply you are making use of the keyboard or mouse and opened the software, selecting the appropriate icons, and goes on giving the responses based on the questions that are raised by that particular software. As I said earlier, in order to create a circle, when you click on the circle icon, it will ask you the center and the radius. Accordingly, you are typing, then it will give you the image on the screen. So IC system, by inputting 3 types of commands to the computer. So to use geometric modeling, the designer construct the graphical image of the object on the CRT screen of the ICG system by giving the following 3 commands. What are they? The first type of commands generates basic geometric elements. So these are called 2D elements or geometric elements. They are point, line, circle, rectangle, these things. So like laminas, they will be created. So the very first input for creation of any object is the points, then lines, then circles, like that. Any image, mathematically definable engineering design object will constructed out of these elements only. The second command type that is used is, once you have created image on the screen, you want to see it in an enlarged form or in the 360 degrees orientation, or move the object from one location to another location. So you require these transformations. So the transformations are of 3 types: translation, rotation, scaling. Translation, without changing the data of the object, you are simply moving its location from one location to another location on the screen area. Then rotation, by selecting a particular point, you are rotating the object to see on the other sides. Then scaling, or simply you can call it a zooming, increasing or decreasing the size. These are called transformations of the image. The third type of command that is used to join the various elements into the desired shape of the object being created on the ICG system. Once you have created individual components on the screen, now you need to create the assembled component. So you must use the assembly command, axis coincidence, surface to surface coincidence, and you join in a proper way all those components so that the final object is created. So in this way, you are making use of the 3 elements for the creation of the image, and transformations and assembly elements, so that final image, the completed 3D image, is created on the screen. So during the geometric modeling process, the computer converts the commands into a mathematical model. You are not creating the model, it is converting the data given by you to a model on the screen, and finally it will store the entire information as data files and display it as an image on the CRT screen. So the data of a rectangular circle is stored inside, and the rectangular circle are appearing you on the screen area. So this is the beauty of the geometric modeling element of the CAD system. So here this is some more explanation about geometric modeling. There are various methods of representing the object in the geometric modeling. Simply a rectangular block, if you require a cube. So how you can create? You cannot directly creating the cube on the screen. First you are creating the rectangular block, then adding the material in a specified direction, then finally you will get the object. So few of them you can see: wireframe modeling, then surface modeling, then solid modeling. What is this wireframe modeling? If you see the first image on the screen, if you see the first diagram on the screen, in this form the object is shown by interconnecting lines. So it can be of 3 types. So no solid information is appeared on the object. Only in the form of wire elements the object is created here. So it is of 3 types: 2D, 2.5D, 3D. What is 2D? 2-dimensional representation of a flash object, only length and height, width. 2.5D, somewhat beyond 2D capability by allowing it nearer to 3D. That is the sidewall information, surface information. In the first diagram, if you see, that is the wireframe modeling, which is by the creation of interconnected lines only. Whereas in the second diagram, it is called surface modeling. Surfaces are introduced for better understanding of the image. So beside interconnecting lines, the surface of the object will be introduced for the better understanding of the design of the object. That is the surface modeling. Still, solid information is not added here. When you come to the third, solid modeling, most advanced method of geometric modeling uses solid geometry shapes called primitives to construct the object. So the complete solid object, that is the third one. So these are the three levels of geometric modeling, so that the user can easily understand the object completely. Then once the geometric modeling stage is over, the object is created in all its respects. The next step is called engineering analysis. It corresponding to the analysis and optimization of the previous stage, the design process, what we have discussed earlier. In the formulation of nearly any engineering design project, some type of analysis is required. You cannot create the object and directly give it for manufacturing. You must test it, the heat transfer calculations, kinematic calculation, dynamic behavior, everything. If it is satisfied, then only you can give it for manufacturing. So the analysis may involve stress strain calculations, heat transfer computations, etc. All these things are carried out. So the computer can be used and aid in this analysis work. So there are generally two methods which are adopted for this analysis purpose in the engineering analysis in the CAD process. One is analysis of mass properties, and the second one is finite element analysis, the most popular way. So what is this analysis of mass properties? In the analysis feature of a CAD system that has probably the widest application. This feature is used to analyze the properties of a solid object such as the surface area, weight, volume, center of gravity, and moment of inertia. So these are basic things must satisfy for the design of the object. It is also used for a plane surface to analyze the perimeter, area, and inertia properties. Then finite element analysis. So the advanced analysis procedure in the engineering design, finite element analysis procedure. So it is the most powerful analysis technique of CAD system. What is happening in the finite element analysis? The entire object is divided into number of fine elements, large number of fine elements, and you are imposing the constraints into a single element and integrating it for the entire object. So in this technique, the object is divided into a large number of finite elements, usually rectangular or triangular shapes, because they are mathematically definable form and it is easy to do the analysis also, which form an interconnecting network of concentrated nodes. Then the entire object is analyzed for stress strain, heat transfer, and other characteristics at each node by using a computer. So in order to fulfill your requirement, you will carry out at the nodes, at the joining of these interconnected nodes, elements. The entire object is divided into, as said we earlier, rectangular or triangular components. You are selecting one particular rectangular element or one particular triangular element. At the joint area, at the node, you are imposing all these constraints and you are testing it, integrating it for the entire object. At last, by determining the behavior of all the nodes, the behavior of the entire object can be assessed. So in this way, finite element analysis will support you. So this is called engineering analysis. At this stage, if you identify any errors, again you will refer back to geometric modeling area. Again the designer will create some design alternative solutions. Again the iteration procedure starts. Once it is satisfied, the next step we call it as design review and evaluation. It corresponds to the evaluation phase of the previous basic general design process. Checking the accuracy of the design. That can be done easily on the graphical terminal. So whether it is perfect or not, we are checking it here at the review and evaluation stage. So semi-automatic dimensioning and tolerance routines help the user to reduce the possibility of dimensioning errors. When you click on the object, it will give automatically all the dimensions and all with the 0.00 accuracy level, so that you can easily identify the dimensional variations and correct them into the correct value. The designer can zoom it on a part design details and magnify the image on the graphic screen for close crudity. Simply making use of transformations, you can increase the size and verify whether interconnected lines are exactly connected or not, or there is any gap. You can easily identify here. Any errors are there, immediately you can take the corrective action. So there are few techniques which are used for design review. So how you are doing means these are the 3 steps. Layering. This procedure is often helpful in a design review process. It involves overlaying the geometric image of the final shape over the image of the rough casting. So first you have created one thing, the final object with exact dimensions is created. So simply overlaying it on that one and verifying whether it is exactly coinciding or not. Any things are there, you can replace that one. This is done to know about the availability of sufficient material to accomplish the final machined dimensions. So any object when you are creating, it should be slight tolerance upper limits you can create, so that at the next stages for the surface finish stage, if you do the finishing activity, exact dimension will comes to you. At the basic level, if you prepare it at the exact level, when you are going for surface finishing activity, under dimension component will result. So you must keep it in mind also. This procedure can be performed in stages to check each successive step in the processing of the part. At every stage you can do this layering. Then interference checking. This involves the analysis of an assembled structure in which there is a risk that components of the assembly may occupy the same space. Once you have created individual components, you have prepared the assembly component. When you are doing the kinematic analysis, the dynamic behavior, any overlapping is there, you must verify that one. Though this risk occurs in the design of large chemical plants, air separation, cold box, and other complicated piping structures. So this one is very much needed. Then the kinematic analysis. One of the most interesting evaluation features available in the design review evaluation in the CAD process is kinematic analysis. It provides the capability to animate the motion. So when animation is going, you can very easily understand what is happening, whether exactly it is moving or not, any overlapping is there, any coincidence is there, collapsing is there, everything you can understand. Of simple design mechanisms such as hinged components and linkages. Commercial software packages for this kinematic analysis are ADAMS, Automatic Dynamic Analysis of Mechanical Systems. So in the FEA procedure also, you have several number of analysis packages also that we are having, ANSYS like that. That is the design review and evaluation stage. Next, automated drafting. So you are satisfied at this review and evaluation stage. The final thing is presentation, giving the object complete information in all respects to the manufacturing area. So it involves a procedure for converting the design image data residing in computer memory into hard copy document, simply giving the printouts. So the printouts may contains the basic three-dimensional object, the individual components, all the 6 views of the image, side view, top view, front view, isometric view, and everything with the colors, so that the manufacturing section can easily understand. A new designer can also easily understand what the object is. So it involves a procedure for converting the design image data residing in computer memory into hard copy. Automation of drafting process can increase the productivity by 5 times over manual drafting. So there is a comparison also. Some of the graphic features of computer-aided design system lend themselves especially well to the design process, because when I ask you to draw a complete 3D model of a screw jack, you can only draw the 3D model. If I ask you what is the side view, what is the top view, isometric view, you need to draw it again and again. But whereas here in the system, once you have created, simply by clicking on the corresponding icon, you can see all the views. So these features include automatic dimensioning, generation of cross-hatched areas, scaling of the drawing, that is increasing or decreasing the sizes, and the capability to develop sectional views also, and enlarged view of the particular path details. So this all information is readily available by a single click on the automated drafting area of the CAD process. So this is all about CAD procedure, the application of computer in the design process, or you can call CAD process, computer-aided design process. So in the first step, we have seen the basic design procedure, which is supposed by Shigley. The next step you have seen computer-aided design process. By comparing these two, what are the advantages or what are the benefits we are experiencing? Let us see. Improved engineering productivity. The productivity of the designer is improved more. For a given time, specified time, when you compare the basic design process with that of CAD process, there is no comparison. You can produce more number of components at the same time, and shorter lead times. The project completion time is also very less. As I said earlier, you give the basic drawing sheet and I'll ask the person to draw a complete three-dimensional view of a particular object, and the same thing on the system. He can do it within 20 to 30 minutes or some less time also, whereas he take 2 to 3 hours of time. So completion of project time is also very less. Reduced engineering personal requirements. One designer can produce more number of components. No need of number of persons. Customer modifications are easy to make because everything is on the computer system, and any feedback you have received, simply you can make corrections by recalling that image and do. Then faster response to request for quotations. So we are living in a competitive market, so we try to get more and more orders. So immediately you will get and respond to the customer instantly and make corrections and give the things, then he will be satisfied. So that is one thing. Avoidance of subcontracting to meet schedules. So no need to depend on others. On your own you can create the entire project. Minimized transcription errors, because you are not writing manually, so no errors. The things are very legible. You will simply giving the hard copy printouts. That is one advantage. And improved accuracy of the design. You cannot compare the accuracy of a CAD process with that of the manual design process. Then assistance in preparation of documentation. Complete, colored, all views, everything is readily available, and designs have more standardization. So the similar design, if anything comes from the customer side, you can compare this with already existing designs and recall that one, make corrections. That is one advantage. Then better designs provided. Improved productivity in the tool design. Also selection of proper cutting tools, machine tools is also very easy. Better knowledge of costs that are also provided. Few errors in part programming. In the manufacturing area, that is we are going to discuss it about the part programming and all. When the design is very clear, writing the program is also very easy to you, and even it can all be associated with the computer-aided manufacturing process. So errors are also minimized in the part programming. Then assistance in inspection of complicated parts also. By making use of CMMs and other things, the inspection procedure is also very easy. Better communication interfaces and greater understanding among engineers, designers, drafters, management and different project groups, because everything is on the system, everything that is on the hard copy printout only. So if it move from design area to the management, following through all the areas in between, the quality control department, HR department, manufacturing department, everyone can easily understand. These are all the advantages that we are gaining by the implementation of the computer in the design activity. This is all about the basic design process, and the next step, that is called computer-aided design process. Now the next step is called, then in order to make these, to get these benefits, in order to create a component, what is the configuration of the computer for this design activity? Is it completely a new one, or already existing computers are sufficient enough? Slight modifications are needed. So we divide that into computer configuration into two things again, that is the CAD hardware, CAD software. The hardware of a CAD system utilizes interactive computer graphics system. Hardware means the physically appearing things, the keyboard, mouse, everything. Typically a CAD system would include the following hardware components. The name changes only, everything is same. Design workstation, we call it as design workstation. What is this? This is the graphic terminal and the input devices. What are the input devices? Your keyboard and mouse and the screen area. This we are calling it as design workstation. So here you have the graphic terminal and operator input devices. The next one, CPU, central processing unit, with high configuration probably. Then supporting to this CPU, we have output devices like plotters and printers, because we need hard copy printouts, that is also. Then secondary storage devices to store the information also. This is the basic physical configuration of the hardware configuration of the CAD system. In this, in the design workstation, you have two things, graphic terminal and input devices. Only these two, mouse and keyboard, are the only input devices, or is there any other things are there in the computer aided design process? Exactly. Nowadays if you see, the touch pens are there, so many things are, joysticks are there. So we discuss them one by one. And graphic terminal, what are the different types of graphic terminals are available? You have only, very simple thing is called CRT, cathode ray tube. What are the other things there in this terminology? And what about the secondary storage devices? What are the printers and plotters? We discuss them one by one. So the design workstation, the first thing, the very important thing also, because the user and system are interacting with this design workstation only. He is giving inputs, making use of input devices, and the system is displaying on the screen. So it plays a very vital role. The design workstation is the system interface with the outside world. It must accomplish major functions, 5 functions. It must interface with the CPU. When you are typing some information, that goes to the CPU, central processing unit, where the software resides, and from there the image is displayed on the screen. It must generate a steady graphic image for the user. No clumsy or no movable component. A steady graphical image is created on the screen. It must provide digital description of the graphic image. Once you click on the image, how it is prepared out of its length, width, height, everything, every information it will display. It must translate computer commands into operating functions. Means you are typing something that will be displayed accordingly on the screen. Rectangle, it will show you the rectangle, like that operating function. It must facilitate communication between the user and the system. So that is very important need. When I am interacting with the computer, I am making use of keyboard and mouse, and system is displaying on the screen. A typical CAD workstation would consist of the following hardware components: the graphic terminal and input devices. These are the major things. So this is all about the basic computer aided design system, and the basic Shigley proposed system, conventional design system, and computer aided design system, and the benefits, the basic configuration of the CAD computer system, the basic hardware components. When we want to discuss the remaining things, that is the design workstation, the graphic terminal and input devices and all, in the later sessions. Now I am stopping it here. Thank you one and all. Thank you.